Okay, so we have our next example over here. Excuse me. So just uh, take a couple of minutes, maybe pause this video and look at this diagram given to us. Okay, so the diagram has been given to us over here, and we have to machine this component. So we have a number of 10 holes on a circular path given to us. So we have the dimension, and just take a couple of minutes and just think of how you're going to get this done, how you're going to come up with the coordinates to get this particular work done. All right. So if you were to ask me to come up with the coordinates for this particular work given to us over here, but frankly speaking, I wouldn't know how to come up with the coordinates. Okay. I just wouldn't know how to come up with the coordinates with what we've learned so far. I was trying to find out the x and y axis, the x and y coordinates for what we are having over here. I think we will need more information. More information must be given to us before we can come up with that. But since we are just having this, we are having a limited information over here. We'll need a new program, a new code. So this brings us to our next code, which we refer to as the polar coordinates. Okay, so polar coordinates. So with the polar coordinates, we don't need to be specifying x and y values. Okay, so value for x and value for y, which we'll be using the Cartesian coordinate system. So x coordinates, y coordinates. We don't need to be doing that. Instead, what the polar coordinate system takes is distance and angle, or length and angle. So you give it length and angle. So that is what we can use to program this. Okay, that is what we'll be able to use to program this particular work that we are having over here. Okay, so let's look at it carefully. So since we need length and this length and angle, how are we going to go about this? Okay, so from this we can tell that if this was to be our work is 0, the length from this particular hole to this hole is 1 inch. Okay, so it's a radial, so it applies to all the holes. So the length from the center to any of the holes on the circumference of this circle is 1 inch. As simple as that. So we have that. Now, how do we come up with the angle? All right. So let's go back to some of the simple things or basic things we learned in mathematics. And we know that the angle for a circle makes up 360. Okay, so if you have a complete circle, then that's 360 degrees. Okay, we have that down. Now, how many holes are we having over here? We're having 10 holes. Okay, so 10 holes. Let's go back, let's look at it. So we have 10 holes. Right, so 10 holes, 360 degrees. So what do we need to do? Divide 360 by 10. What are you getting? You are getting 36. So it tells us that the angles, okay, so the circles are 36 degrees apart. So that's all. So we have everything we need. So we have the length, and we also know that the circle, the holes to be drilled are 36 degrees apart. All right. So if we are to machine this, okay, so we need 10 holes in a circle, not necessarily at the exact position that they are, but we need the distance to be the same and the distance between each circle also to be kept. Okay, then we can work with that. Simple as that. Okay, so as simple as that. So we have this, and we have this also. So we can start writing our program. So let's look at how it is going to be like. Let me minimize this thing, push it to the corner. Okay, let's start. Okay, what do we need? Program number. Input that program number 6. Okay, now first block as usual, G20, G90. The next block what do we need? We need to initiate an automatic to change command. The zero is really not necessary. If you don't bring it zero up before the number, if you don't bring it, the machine still knows what you're talking about. But I'll still bring it anyway. Okay, so we initiate an automatic to change, and the to number is to number 1. Okay, so the 2 in slot 1. Then also program block number 3. What do we do on block number 3? I want to start my spindle clockwise, and this time around I'm using 1000 revolution per minute. My feed rate is 0.25. Then we can begin with hole number 1. Beautiful. Okay, so hole number 1, block 4. Okay, so hole number 1, block 4. What are we doing over here? So we want to do a rapid positioning. So G00, X should be 0, Y should be 0. Okay, then we can initiate our count cycle. As usual, holes have the same features, so we can use count cycle over here. Block number 5, G81. The depth of drill this time around, Z is negative 0.25. G99, our retraction point is 0.1. Okay, so count cycle has been specified. As soon as we do this, this hole will be drilled over here. Alright, so let's go to hole 2. Okay, so this is where we need to start doing our stuff. So block number 6. So we need to start using the polar coordinate over here. So this is our reference point. So first thing, we move away 1 inch and we draw a first hole over here. Okay, move away 1 inch and draw a first hole over here. Alright, so let's look at that. So to use the polar coordinate, to initiate that, we use J16 to initiate the polar coordinate, and our distance, which we specify that with X. Okay, but this time around it doesn't mean the X coordinate and Y coordinate. So the X this time around is distance or the length. Okay, so the length is 1, which will always be 1 in this case. So X is 1, and what is Y going to be? So since Y is on the same plane, okay, the same line with the origin, Y is going to be 0 for 360. Alright, so we have that down for hole 1. Okay, so we're done. Alright, so I think actually maybe I should have specified over here. I'm using polar coordinates. Oh. Okay. Alright. So specified over there, I'm using polar coordinates. Then we can move on to the next hole. With that done, let's move on to hole 3. So same applies over here. So once we turn count cycle on, it works till we turn it off. So the same thing applies to the polar coordinate. Once we turn it on with G16, when we specify X and Y, it interprets it as the length and the angle until we turn it off with G15. Okay, so let's move on. So polar coordinate still holds, count cycle still holds. So N7, our length still 1, like I said. And we said the circles are 36 degrees apart. Okay, so the circles are 36 degrees apart. Alright, so if we're given the angle, okay, the angle from this to this, then we could have worked with this exact case. we could have worked with this exact case, but since we weren't given this angle over here, maybe extend this line and give us the angle over here to this. We could have worked with exactly this case, but since we weren't given, our priority over here is to just drill 10 holes, okay, at equal distance on a circular path. Still still applies to this. So 10 holes along a circular path. That's all, at equal distance. So that's what we are doing. All right, so what we're going to be doing for the y's, we just keep adding 36, 36, 36, 36, just keep adding them up till we get over here, then we are done. That's all. So this program it looks quite challenging at a glance, but when you come down to it, you notice that it's very simple. Okay, so we are done with that. Let's move on to the next hole. So hole number 4. All right. So hole number 1 was the center hole. Number 2 actually the beginning of the holes on the circular path. Okay, so we are moving all the way to hole number 11. Okay, so then x is still 1. Then what happens to y? We add 6 to it, we get 72. Okay, so hole number 5. Then the block number specified, x is 1 again. So y, this time around, let me just point it over here. 72 plus 36. So we are getting 108. Then we can move on to the next hole, hole number 6. And it's 10. So x is still 1, like we said. The distance, the length is 1 throughout, radius. Okay. Then y, add another 36 to it. So we are getting 144. Let's move on to the next hole, hole number 7. Okay, x is 1. Y, add 36 to it. Okay, so we are getting 180, halfway. Okay, hole number 8 and 12. X is 1. Y is plus 36 to 216. Hole number 9. Okay, so n is 13. X is 1. Y is plus 36. So we are getting 252. So hole number 10. Block number is 14. X1, which is our length. And what is our angle? Add another 36 to it. Then we have 288. Okay. So we have hole number 11. Oh, right. Which is the last one. 36. So n is 15. Block number 15. X is still 1. Y is 324. Okay. So if we add 36 to it again, you notice that we're going to get 360. So 360 will be, the hole is just going to be exactly on hole number 2. Alright, which we don't want that. So we'll end it here at 324 degrees. So that's right. So when we are done with that, then we can move on to the next block. So with the next block, we turn off can cycle. Then the next block, we turn off the polar coordinates. Then the next block, we turn off the spindle. Then the next block, we rewind our program. Okay, so that's it. A very simple way to get this done. So like I said, all we need is 10 holes drilled on a circular path at interval. So that is the approach to get this done. Okay, so with our program written, let's go back to our machine and let's set it up. So first things first, so the dimension is still the same, 3 by 3. Okay, so we don't change that. Okay, so still 3 by 3. We need a new one. Then let's add a new program. Okay, okay, so new program added. So the same thing over here. This is going to be our workpiece 0. Our workpiece 0 still remains the same. So we're not going to tamper with that. We're going to leave that as same. So basically it looks like everything is still the same. Okay. Alright, so let's home this. Okay, let's go to our tool management system. The drill is still the same, also the same, dimension is the same. Alright, so with that done, let's import our program. Okay, no warning. Let's fire this. Okay, so as we can see, neatly done over here, neatly done. So we have our 10 holes on the circular path. So like I said, when you look at this from a glance, it looks so difficult. But when you know the right J code to use, then it will be a piece of cake. Okay, with that done, see you in the next video where we take another example. Alright, so until then, stay safe.